Deep.
What's up?
How you doing, man? So
Good.
We finally got Rajeet, and we're going to talk about what?
We did. We got the man that once promised us that he would spend 1 hour looking straight at the camera. So that's what we're here for today.
Hey,
So we're going to stop the clock now,
sounds good.
and we'll be back in a bit.
Okay.
Just 1 hour?
Just 1 hour.
As long as you want. I mean, honestly, as long as you cross an hour.
Nice.
I don't think people want to put up with that.
They don't want to see
I don't
that.
think
They
so.
want to learn about hosting.
They do. All right. So we've got Rajeet with us here today for another video in our series. Please introduce yourself, sir.
I'm Rajeet. I'm a software engineer on the Service Fabric team. What else?
How long have you been on the team?
In Microsoft, I have been about 15 years now.
Nice.
Started off with Windows Core Security, working on XP, SP2, and Windows Vista.
Right on.
On Service Fabric, I think a little over 6 years now.
Okay.
And during that time, I have owned hosting, some parts of security, and some manageability stuff.
Cool. So we're going to spend some time talking with you specifically on hosting, exploring hosting and how it fits into the overall set of different subsystems we've been going through for Service Fabric.
Sounds good.
And we'll talk a little bit about containers as well, because you've been pretty instrumental in containerizing workloads that run on Service Fabric.
Sure.
Yeah. So let's get started with the hosting piece. So could you tell us a little bit about what that is? What is hosting for those that aren't as aware? And then what are the interactions between hosting and some of the other pieces that people are learning about, like CM, for example, when we were in here with Alex a couple weeks ago?
Sure. So hosting component essentially has three pieces. The first one is Fabric Host, which is actually the service or daemon that starts up, and it's responsible for starting Fabric itself and other system components like DCA, Fabric Gateway, and it manages the lifetime of those processes, upgrades, shutdown, and so forth. The second component of hosting is the hosting subsystem that actually lives inside Fabric itself. And that component is responsible for downloading application images, setting up the user application environment, activating, deactivating processes, containers, doing elevated operations on behalf of users. So what it does is it actually makes requests to Fabric host to do these elevated operations. Fabric host runs as local system or root, and Fabric runs as a lower privilege process. And then whenever it has to do elevated operations, like spawning a process or activating container, it calls Fabric host, and Fabric host does that. The third component is actually the application host that lives in users or service host. So that's the one that's responsible for actually registering the runtime with Fabric and creating an IPC server and IPC client connection. And so from there, reliability can actually reach into the user service host and say open replica, close replica, and all those things. So these are the three different components, broadly speaking, that essentially drive hosting.
And Fabric Host is something that people can just go to a machine where Service Fabric is running today and look up fabrichost.exe.
Correct.
And they'll see it running alongside fabric.exe and several other processes.
Correct. So that is the NT service or a daemon that starts up. That's the first service that starts up and brings up all the other services.
Cool. So can you draw us a little picture of how hosting sort of fits into Service Fabric as well as why we have it?
Sure. I can use the whiteboard for that.
Cool. That's pretty quick to the whiteboard. Impressive.
I like going to the whiteboard.
So Fabric host is actually the agent that does elevated operations on behalf of Fabric as well. So it has a few components here. The first one is something we call the hosted service activation manager that starts off hosted services, which is Fabric, DCA, gateway, and so on. And then there is something called process activation manager. And this one is responsible for activating user service hosts. When user deploys a service, this is the one that's actually responsible for starting those processes. In addition, it has other components in there, like HTTP security provider, firewall security provider.
So this is where all applications,
Correct. And so what it does is,
goes to us.
so when you go and set up an application, you just can't start that application. Right? You have to set up the environment for it. What are the users you want to use, and under what user credentials should the process run under? What are the certificates the app wants to use? So setting up all those things is actually the responsibility of process activation manager.
Right.
And in addition to these two things, there are a bunch of auxiliary helper classes that it uses to.
Sure.
And then here, the first thing this guy does is when it comes up, it starts off Fabric. So Fabric itself has the hosting subsystem in there that talks back to Fabric host and registers itself saying that Fabric is up, and now it will start making requests to activate user service hosts.
Why is it that hosting is doing that? Why isn't that CM, for example, or one of the first things that comes up like FM in this case?
FM comes up, FM talks to other nodes and makes sure that FM is ready, but the responsibility of hosting subsystem is activating user service hosts and making elevated operations. So that's why hosting subsystem is responsible for talking to Fabric host and registering itself. So once that is done, Fabric host checks whether it's the right process. It can make connections to Fabric host and everything. And then once that's done, it says, okay, you're ready.
So this is kind of us saying now we're ready to handle incoming applications.
Correct.
Okay. So until this comes up, even if Fabric technically has started and can fail over things, nothing's actually been deployed and nothing will be able to be deployed without hosting.
Correct.
Can you ever deploy stuff without the hosting subsystem in Fabric, or is that a requirement?
You can. So there is something called self-activated user host, which means you can activate your user services yourself, but not many customers do that. And it's actually, I want to say it's not supported anymore,
cool.
But the code is still there.
So hosting comes up, informs Fabric host that it's come up.
Correct.
Now what?
At this point, it's ready to actually get requests from users on deploying applications. So let's talk about the flow. What happens is a client makes a request to CM to create a service. CM downloads the packages from image store. Looks at the types and says, okay, I can create this service, and creates an entry and forwards it to naming. From naming, it goes to FM and to create the service.
Right. And as we learned, FM is the thing that keeps the library of all things in the cluster. It's fully aware of all pieces.
So now when FM gets this request to create a service, it talks to PLB and says, where can I place these services, right? It can have multiple replicas, and it says to PLB, go ahead and tell me where to place these guys. So PLB will go run the algorithms, look at the capacity on each of the nodes, figure out what's the requirement of this service based on its resource governance policies.
And I mean, some of our users don't actually set resource governance.
So there can be some placement metrics also, right? You're using, if you're not putting some placement constraints any of those things, then it's fine. But you still have to evaluate the node capacity and see where you can place it.
Correct.
And once PLB does that, it tells FM back, go place these services there. So what FM does at this point is say, FM got a response back saying, put this guy on node 1, just for example. FM will talk to node 1 here, RA here, reliability subsystem, and say, create this service and place this replica here, right? It just says place this replica. RA talks to hosting and says, hey, I want to create a replica of this particular type. Do you have a host running that can host this service? And so hosting looks at its table and says, no, I don't. So I need to activate it. So when RA does a find, which we call a find operation, it actually sends the information about application package, service package that should be used. Based on that, hosting talks to image store, downloads the application package first, looks at the application package, what are the users, certificates, and all those things required, sets those up, and then says, okay, now I need to download the service package. It downloads the service package, and from that it can see what are the processes that need to be started, or what are the containers that need to be started based on the images. At that point, it's ready to actually talk to Fabric host and say, go set up this environment and start these processes. So Fabric host will go start these processes or containers, and it starts monitoring them. This is the key part, because what happens is if your process goes down, Fabric host will detect that, and it will inform Fabric saying, hey, by the way, this process is down. Hosting can from there know what runtime it was registered under and tell RA, which RA now detects and says it's a failover. I need to tell FM, and then from that point on, it's a failover thing that kicks in to place it on another node, or if it's a stateful service, it might come back on this node.
So one of the things you pointed out in this flow is RA has to check with hosting if there's a process that already exists that can host this.
Correct.
And the answer is no, obviously, when the first time something is being deployed to the node. In what cases is the answer yes?
If you're doing a reliable collections or reliable service case, what happens is you have registered the service type, and you just want to open another replica, say another partition for that.
Sure.
In that case, this process is already up, and we
Sure.
can use that to actually host the other replica there.
What else? Is there any other case? Is it possible that because of a failover, process migrated to another node and then it comes back? But in that case, I assume the process has been killed, right, on the node?
Yeah, so I mean, usually what happens is with first process that use a reliable runtime or reliable collections or reliable service like that use a runtime, what happens is when the process actually goes down, hosting immediately brings it back up again. Says, regardless of whether this guy is placed there or not, I'll bring it back up again. And so the thing what happens is if RA happens to place the replica on the same node again, we can reuse that guy. If it moves away somewhere else, it's fine. Hosting will tear it down after some time.
Cool.
So we have something called as a grace period. We keep it up for that long to see if RA wants to place the replica there.
Back.
Yeah.
So actually, there is a point at which you have more than the stated number of replicas of your processes running in your cluster for a small amount of time. Because if I've requested 5, 1 fills over, the 6th one comes up, hosting pulls back the 5th one.
We pull out the process. No, the replica hasn't been opened there.
Correct. So then, but there's still a point at which you could have possibly had very cheaply increase the total number of replicas as well, because the process is already running on an additional node with all the data in it. Right, because you put yourself in a situation where you have 5 active replicas, you have a 6th machine that has the process running that could very easily also go a replica.
That's true.
Interesting. Okay, and how does this differ for containers versus guest executables versus service fabric services?
So what happens is, so remember initially I told you there are 3 different components. So
Right.
we spoke about fabric, we spoke about fabric host. We didn't speak about the user service host itself.
Okay.
So when a user process comes up, assuming you're using service fabric runtime and it's not a guest exe, what happens is there's a hosting component here called application host. So what this guy does is it talks back to fabric and registers itself saying, hey, I'm the application host, and then at that point it can register its service type. And now what happens because of this is that hosting knows what's the type you have registered and what kind of replicas you can open.
Sure.
And because of this IPC connection, this is the one that hosting forwards to RA so that you can use that channel to talk back to the user service host. But when you're doing a guest exe, you're not really using our runtime, right? So how do we actually start your processes? So what we do in that case is, when we see the way you do guest exes is you put saying is implicit host true, right?
Yep.
So what hosting does is when it sees this attribute, it says, oh, you're not going to use a runtime. So what we'll do is we'll register the runtime on behalf of your application, and then we can do open replica on that. So what we are doing there is we register the replica, we do the state machine thing for you, but your container just comes up or your guest exe just comes up as an auxiliary process there. And so what happens is we monitor this guy, your process and your container. If that goes down, we kill this guy, which actually triggers the failover.
Interesting.
It is.
So the user process host, where does that run? That runs on each node as well?
Service host?
So yeah, sorry, service host. Or is that per service?
So user service host is just your process, right?
Right.
It runs when, so you can have a service package that can have multiple code packages. Each of them can have a process in there. And so when we activate, our unit of activation is a service package. And in case of containers, also it's a service package. So you can have multiple containers and they'll all be activated together and they'll share all the namespaces.
Mm-hmm. But they won't necessarily be in the same process, because we do have a toggle that allows you to set your policy whether or not you want them to be in the same process host or not.
So that's a slightly different, subtle but slightly different concept.
Okay.
So let's talk about that. So what happens is I have a service package that has 3 code packages, right? CP1, CP2, CP3. Well, let's say all 3 are processes, not containers. So now you registered a service type with this guy saying I am part of application A1 with service type as P1. Now if another partition gets placed on the same node, like we spoke about earlier, right? I can cheaply call this guy and say open another replica. But you might say, I don't really want this. I want this guy to have its own separate process because I want to do resource governance on top of it. I want to keep it separate. and I want isolation across the two processes. It's not a security boundary, but I want them to be isolated. So at that point, what we do is, instead of actually starting a replica inside this guy, we bring up a new service package for you and then open the replica there.
Interesting.
So those are more useful cases, like you don't want to share the ports across these two services, right? You want to say, these are TCP ports, I don't want to share them, I want them separate ports allocated, separate firewall policies. That's how I want to do it. So
Awesome. And I just wanted to say that Al was asked questions. Thanks, Al. And you've actually already answered Al's questions before we even asked them, which I think is awesome. It sort of shows that Al's a fairly smart person.
Go Al.
So EXEs that you host don't get controlled by the runtime, right?
Correct.
However, if you have an EXE who only is supposed to do some things for 20 seconds and then go away, like shut off, Service Fabric starts it again.
Correct.
Is there a way for me to say, don't do that? Do not start this again?
Not today, but there is.
There is going to be. Okay, great. Because that's why I'd like Cloud Bedlam to run as a stateless service. But I can't, because the EXE will go
Keep
create a
going
bunch of havoc, go away, and then come back again, and all of a
Right.
sudden your network stack is broken.
Right. So I want to talk a little
So anyway, thank you for that information. And Al, thank
So-
you, brother.
So I wanted to clarify something that you just mentioned, that user services with guest EXEs and the normal reliable services case, both of them are managed by Service Fabric runtime. The only difference is in one case, the actual runtime lives inside your process. In the other case, it does not. So we don't have insight into your process if you're not using our runtime. But we will still do the lifecycle management for it. We'll start it. If it fails, we'll restart it. We'll drive it through the upgrades and all those things for you.
Absolutely, because it's running as a service
Correct.
that you're controlling, but the actual binary stuff that's being done is outside of your purview because you have no idea what the guest EXE is trying to do. It's actually one of the cool things about Service Fabric is that I could run any EXE that I want, any binary that I want, not just a website or a blah, blah, blah.
But it is important, though, to note that even though we just treat them as processes, when they come in and we can do a whole bunch of lifecycle things, we also treat them as black boxes where we have very little knowledge of what's happening inside. So for those of you that are working with guest EXEs, you should still look into educating Service Fabric a little bit about what's actually happening inside. So using, for example, our health model to tell us when things are going right and wrong, or writing custom health reports. So one, that stuff shows up in Service Fabric Explorer and you can do things with it, or events show up where you can alert with them. And also two, we don't accidentally start rolling back upgrades because we thought something wasn't happening the way it was. Or we are more correctly rolling back upgrades because even though the process came up, your actual application may not be running as expected.
So what if the EXE, and I'll point the camera at you because this is probably your domain or your fault. So
His fault domain.
one of the things that this is your fault domain. So Service Fabric, we learned this over the course of this series. The number one thing that Service Fabric guarantees is consistency, data consistency, over everything else, availability, blah, blah, blah. So my question for you would be is if I have a guest EXE, and this guest EXE, for example, let's say it's SQL Server. Well, that's probably not a great example, but it's something that's going to be managing data. That's outside of your purview because you don't know what my EXE is doing. So that's why I just asked the question.
There is some things we are working on, which we actually previewed and gave demos on during build, which is using Service Fabric backed volume drivers inside your containers. So what we do there is, because your service is not using a runtime, but you're just using a volume, a disk that's mounted inside a container. But Service Fabric is backing that, so it knows whether you are the leader or not, whether you are the primary or not. And when you fail over, it knows to bring it and not allow you to write any more data to it because it knows that you have failed over, someone else is the primary at that point. And we can actually take it further and say, you said you want a replica set of 3. I can just start one container for you, which is your primary. The secondary set might just be replicating data. So our volume driver is on the background replicating all the data for you. But if you fail over, we'll only start the secondary at that point, saying that, okay, now this guy becomes a primary, so I can start a container there. So it's actually not even consuming any compute resources for you.
Awesome.
Yeah.
Really, really cool. But I mean, this is important stuff to talk about.
So I want to ask a little bit more about the architecture of how hosting was set up.
Yeah.
So we have Fabric Host, which is a service that's responsible for bringing out Fabric.exe, but RA and hosting are actually running inside Fabric.exe.
Correct.
But for hosting to actually get things done on the node, it's going back to Fabric Host.
Correct.
Why isn't hosting running in Fabric Host?
The reason is security. It's got a defense in depth. Fabric itself is listening on the network for incoming, for managing leads and talking to other nodes. We want to make sure that Fabric Host, which is actually running as local system or root, is not listening on the network and it's not exposed to the network that way. So what it does is, it actually, when it starts Fabric, it gives a sit on the Windows case and says, only this guy can connect back to me. And so it knows only Fabric can connect back to me. But what it does is, it has a certain set of operations only which it can do. It's not an elevated process just running on the machine for you there.
Interesting.
Makes sense. So what if FabricHost.exe got compromised?
Yeah, that's
Steve?
exactly what I was going to ask next.
FabricHost.exe never listens on the network.
So that's security in depth. That's what you mean. So you're secure by design.
Correct.
Cool.
I like that's important. You hear that, Al? Secure by design.
And so you're also, on our team as you get very busy because you're one of the main people, you're the backbone of hosting. A lot of incidents come your way. What are some of the most common problems that you see going wrong in the hosting subsystem, or the way in which people use or deploy applications through hosting that end up causing pitfalls down the line?
It's a good question. I think there are a couple of things I want to talk about. One of them is a feature that we have that not many people know about, which is called shared folders, which is where we actually let you share code packages across service instances. So when you deploy the application, you say, I want this shared. So what hosting does is it actually creates a separate shared folder for you where all your code, config, and data packages live. Now all the instances of your service that come up can all use that particular folder. What we recently saw were people who were not using it, so they had like extremely large code packages and they deployed hundreds of instances and then their disk space starts filling up. And when they fail over, remember, I think we should talk about it later as well a little bit more. What we said, we leave process up for grace period. So now it's not even torn down immediately because we want to keep the cache around.
Correct.
And make sure that if it fails over, we can bring it up quickly.
Eats up more space.
Yeah. So
Interesting.
So we have seen cases where people are not using shared, and so they run into issues where the disk space is filling up. That's one issue. Another one we have seen is where people have HTTP ports that they use across applications and bind it to certificates. So what happens there is, great, initially everything works fine. You're using HTTP sys, it's managing all these things for you. But now you want to upgrade one of the certificates. What happens? We can't let you upgrade it because there's another application on the node that's using the same port with a different certificate. So now you're stuck there. So we do report health on it, saying that you cannot do that. But the best practice is actually, in such cases, have your own gateway that actually routes the request to these applications in the backend.
Interesting.
We got to get this guy writing some blog posts, man.
We should.
Well, we see these issues all the time.
We do. Yeah. It's one of the hardest things to pull off in Service Fabric is securing things correctly everywhere.
Got it.
Yeah. And what are your comments on the common code package activation failure that people keep running into?
Yeah, so there's another feature that we have, which I don't think not a lot of people use, which is called console redirection. That's a great feature. What we do is, when your application fails, we actually capture its console out and console err and dump it into the application log folder. So you can just go and look and see what exactly your exception stack was, what was the process actually doing just before it crashed. So that will give you additional information on things there. We do report the health based on stuff we know about, like what was the exit code, or if your process never launched, if like DLL not found or something, we'll return those for you. But if it's your process doing something internally and it crashed, you can enable console redirection to get more information from there.
Sweet. Let's switch gears a little bit, talk a little bit about containers too.
Okay.
Because we've got the man in the room finally, and he's saying things, not just staring at the camera. So you may as well leverage.
Yeah,
I can do that too.
It's 2018, right? We have to talk about containers.
So talk to us, Rajeet.
So you were asking why containers. So
And also how containers, not just why.
yeah, so Service Fabric supports container orchestration as a first-class concept today. But when you talk about container orchestration, it's important to differentiate and say Service Fabric is not just a container orchestrator. It's a full-fledged distributed application platform. So it gives you not only container orchestration, but it actually solves the hard distributed computing problems underneath. So it does stuff like redirection and the stuff that we spoke about with volume disks that we can do better because we know you're the primary or you're the secondary. So we're not relying on any other store to actually do the hard distributed computing problem. So that way, when you're doing lift and shift to first move to cloud, you can take containers as a way to encapsulate your dependencies and do resource governance and immutability and all that. But you can take it further with Service Fabric because of the distributed computing capabilities we have here, right? So you can we want to build reliable, highly available services. Then Service Fabric lets you build that.
That's awesome. I mean, and people learned about this in the Gopal video.
Yeah.
Right? I mean, this is what you get with Service Fabric. You don't just get container orchestration. And of course, Deep knows this. I mean, give me a break. But the moral of the story is you wanted to dig into sort of how do we do container orchestration in the hosting context.
Yes.
I mean, obviously, the most incredible thing about Service Fabric is the fact that it's a distributed systems platform.
Sure.
Container orchestration is just something it does.
Yep. So I also want to hear a little bit about the story too. You know, like you're the container man on our team. What did it take for you to get us to be in a place where we're also a GA container orchestrator? Walk us through the last 2 years of your life and getting that in place.
A lot of fun, a lot of hard work, but primarily a lot of fun.
Cool.
Like Gopal says, don't be afraid of taking risks, right? And sometimes it's useful to just jump head on without knowing what you're going to do and figuring it out. You learn a lot. And so containers were like something like that. But it's kind of cool that it's all come together now. And so.
And our million container world record setting demo, how did we do it?
We did it.
How are we so fast at placing and deploying and launching containers?
That's testament to the whole system, right? The system is built for scale, and the way every single piece works together in this system, that's why we were able to achieve the scale. So activation is one part of it, right? Placing, FM getting the request, CM first getting the request, getting to FM, PLB making the decisions to place the containers on the node, and then from there on actually activating. How do you optimize the whole path from that?
It's amazing.
Yeah.
And I think it speaks to the loosely coupled nature of the subsystem components, and they were specifically designed that way, right? So you have no idea whatsoever what's going on in Federation, and you needn't. But you do care about, like, when you ask a component to do something for you, that it does it for you.
Correct.
But you don't crash if it doesn't. Yeah. So it's the loosely coupled nature of the system is really impressive. But anyway, but I do want to listen. Are we allowed to talk about Seabreeze today?
Yeah, absolutely.
So because we're gonna be live by the time this video's out.
Yeah.
And so, and again, guys, this is like we're talking a few days here. So this isn't like we didn't film this a long time ago. Anyway, let's talk about that. Let's talk about what's your world like in mesh world, Service Fabric Mesh. Talk to us. Hosting and Service Fabric Mesh.
So hosting by itself as a loosely coupled thing doesn't really worry about whether it's hosted in Service Fabric Mesh or you're using the cluster.
I understood.
Method. Yeah.
Understood.
And so there are certain requirements that come through because of Mesh, because now when you're actually owning the whole cluster, we can mount your volumes inside a container or pass in your environment variables that gives you more context about the environment you're running in. Mm-hmm. But when you're running in a mesh environment, which is multi-tenant, you're not going to get that information in there, right? Mm-hmm. You're not going to get a volume mounted from the host into the container, or you're not going to get environment variables that tells you how to talk to Fabric.
Got it.
So, and you won't get a Fabric client certificate, for example, inside a container. Mm-hmm. So when you do a mesh, we have to actually make sure that we are actually isolating your workloads so that they cannot see more than they can they need to see, or do more than they need to do on a particular node.
So how do you know as a subsystem? So Service Fabric Mesh is a stateful and stateless services built on top of Service Fabric. Correct. It's not like Service Fabric plus.
Correct.
So how do you know as hosting that you're actually dealing in the mesh environment? What are you told? Who tells you?
Yes, I don't need to know whether I'm running in a mesh environment.
You don't?
I don't. But the advantage is CM can tell me whether I need to pass the runtime information to a container or not, right? Okay. And that's enough for me.
All right.
And so from that, I don't care whether it's mesh or any other system that's built on top of Service Fabric. As long as I have enough information about what you want to do with the container, I can pass in the relevant information or hide the information.
So what are some fun issues that we still have yet to solve in the hosting world that perhaps some sprightly engineer listening to this conversation could help out with?
I mean, there are things we are working on that's in the pipeline. That's interesting stuff coming along around activating of user containers, how we can do order stuff like we spoke about. If your process goes down and you don't want it to be restarted, how do we manage that?
Yes.
And stuff like, even more interesting stuff, you say that I want these containers to be activated in an order. Only this guy should come up first, and he runs, and only based on request, you start the other containers kind of thing. So how do we do that? So
what are some scenarios in which you anticipate people using that?
So I want to run some statistical analysis on data, but it's based only on request, right? I now have the data, I want to run it, but I don't need to run my containers all, because I might not always want to do that, right? Based on request, I want to run some analysis. I start that code package, get the work done. Once it's done, I'm done. I pass the result back to the client. Then I don't have to keep the container running. That actually brings me to an interesting point that customers have asked before, which is how do we know whether your container has actually started, or how do we know whether a container has actually stopped doing work before you tear it down? So today what we do is we register the runtime on your behalf if you're using a guest exe, right? We don't know whether when you're truly actually doing work or ready to do work. So when we publish the endpoint for you with our DNS, we do it based on when your container started. That might not be the best time to report the endpoint address because your service might not be ready at that point. Right? If you're using a runtime, you do it on your open, right? So you are saying, I'm ready, I can publish the endpoint now. Mm-hmm. But when we are doing it on your behalf, we don't have that information. So we are working on features to actually improve that. But in the meantime, you don't have to depend on us to actually solve it, because the way the system is architected, you can actually solve it yourself, which is what I wanted to talk about here.
Okay.
So remember, I spoke about guest exes where we said we register the service type on your behalf. So if you want to control the lifetime of your containers and see when to publish the endpoint address and when to shut it down, instead of using the guest exe feature, you just write a exe. Remember, Service Fabric supports both containers and processes, right? So you write a small process that registers the runtime with Service Fabric and does the open replica. So you can have this one process there that does that for you. And you have your containers here, container 1, container 2, and so on. So what happens is, because you register the runtime, even though we bring up these containers at that point, you can actually query the state of these containers on that node and figure out whether this guy is ready before you actually publish the endpoint address. Similarly, when you get a change role, say from primary to say secondary or none, you can actually flush out the queue of all the work that is there before you actually return, so that we make sure that all your work is done, and then that's when we actually tear down your containers. So this is the work you will have first-class support in Service Fabric for this, but you don't have to wait for it. You just have to implement a small stateful service exe, and that will take care of it for you.
Interesting. Can you tell us also a little bit about the code package that comes to hosting to start up a service? It consists of config code, and it consists as well of data, which is something that is kind of underutilized. Actually, I don't really see a lot of people using it. Can you tell us a little bit more about that? When should people use it, and why has it been provided?
So data is typically, you can use it for both containers and processes. You have a lot of read-only data that you want to share across a lot of EXEs, so you put it in your service package. And so now what happens is, when we activate the service package, you get information about you can use our runtime to query and say, hey, where is my data package? So we'll return you the path of it, and you can go and look at your data. Config is the configuration that you want to use in your service. You can specialize it as part of your deploying an application using application parameters. So say you have a SQL connection string. You just put that placeholder there in your config, but during deployment, you can actually give the actual value to us. And at runtime, you say, what's the value for this? We'll give it back. So that's a use case for your config.
Right.
Data is actual read-only data. That's your startup data, right?
Seed data of any sort before you...
Correct. And so you can use that with containers as well. So what we do is, when we download the code, config, and data, we use the config and data and mount that inside the container. So that's available to you as well.
Cool. And again, last question from an architecture perspective.
Sure.
There seems to be a pretty intricate relationship between RA and hosting, because obviously this is the one receiving requests before they get to hosting. What other elements in Service Fabric have contracts set up with hosting, and what are those contracts?
So RA, the way RA works is on what initially does a find, And then there is when the replica shuts down, it does a decrement of the replica as well. So when the replica count goes to 0, we know that this process can be cleaned up. We leave it around for a grace period, saying just in case another service got placed there. But once that grace period is over, we tear down the.
How long is the grace period?
Default is 1 minute, I think, but it's configurable cluster manifest. The other component is, I think Alex briefly spoke about it, I'm not sure. But what it does is, hosting subsystem, when it's actually trying to delete packages on a node, say all your applications are gone, or say a few applications are gone, some service types have been unregistered. So hosting needs to know whether it's safe for it to actually clean up those folders. How does it do that? It can go and delete them, but if the service gets placed there again, you're again going to download it back there, right? So it's a waste of effort there. So what we do is, at this point, we actually make a list of all the application packages that we have based on application types and instances, and then query CM and say, what are the application types and instances still alive? Based on that, we can make a smart call on which ones to delete and which ones not to touch. That actually takes us forward to image management also. Container image management kind of leverages the same scheme. So when your disk starts filling up with container images, we can go and delete them, saying, oh, 80% filled up, go do container image prune. What image prune will do is it'll just go ahead and clean up images that are not used at that point. But that's not safe, right? Imagine I'm doing an application upgrade. I just moved over from container image 1 to 2, and prune runs, cleans up 1. But 2 has a health problem and it will roll back. At that point, I have to re-download the image. So we can't do that, right? So what we do is we actually query CM and say, is this type still in the system? If the type is still there, I cannot touch this image because I know that you are telling me that this type is still important for me, so I'm not going to touch that image. So we leave the image back.
But V0 in this case could have been cleaned.
Correct.
And on that topic, let's talk a little bit about why you can't use the latest image tag on a container when deploying in Service Fabric. Well, you can use latest, but why you shouldn't?
You can use it, but we recommend that you don't use it, primarily because you want an immutable image, and you want to, for example, you want to do a scale out, right? You had an image version 1 with latest, and then you updated it to something else, you kept the tag latest. You scaled out, now you have multiple instances running, all of them are running different versions of the code. You don't know which one is running. And when the load balancer is routing requests, you don't know which one is going to, right? So that's not the best experience you can have. Now when you scale in, which one is taken out, you don't know. So that's one reason. The other reason is, the way we do upgrades is, we do a diff of the manifest to see what changed, to make the call on what we should shut down, what we should tear down. And FM uses that, Fabric hosting uses that to tell these are the code packages and to restart. If you don't tell us that, we look and say, this is latest, you want to move to latest. Okay, I'll leave it there. That might not be the experience you want, all right?
You actually probably want to get your latest updates. Yeah, I would imagine.
Sure.
If you're doing an update.
But you told me that it's latest, so it's equivalent, right? So I could argue that.
True.
Yeah.
True. All right, cool. So if someone wants to go to GitHub and contribute to hosting, what would be your recommendations? How should they get started?
So the first thing you should do is look at the hosting state machine for different components, because hosting is a very state machine driven code base. So understand the state machines for different applications, services, code packages, and understand how they transition and what guarantees we provide at each transition. So once you understand that, it's pretty straightforward to make contributions.
Cool. And any best words of advice for somebody who's attempting to go into this?
Keep calm.
Awesome.